So the next topic we're going to take a look at is graphing a quadratic function that is in vertex form. So the first step is to identify the vertex. So remember, if it is grouped inside the asylum with the x, it is not normal, so our -2 is going to come out of the asylum as a +2. Outside the asylum, we've got a +4. It is normal, so it stays +4. And another way to keep this straight is if it's grouped with the x, it's your x-coordinate. If it's not grouped with the x, it's not your x-coordinate, so it's your y-coordinate. Once you have the vertex, we're going to set up a t-table. And the vertex will go in the middle of the t-table. We're going to choose 2 points on either side of our vertex. So I like to use the ones close to it, so I'm going to do 1 and 0, and 3 and 4. Substitute those points into the function to get your y values. So substituting 0 in for x, 0 minus 2 is -2, squared is 4, plus 4 is 8. Substituting 1 in, 1 minus 2 is -1, squared is 1, plus 4 is 5. Substituting 3 in for x, 3 minus 2 is 1, 1 squared is 1, plus 4 is 5. And substituting 4 in, 4 minus 2 is 2, squared is 4, plus 4 is 8. So now you may be noticing a pattern in our t-table. Maybe that only worked on this one. I don't know. We'll check it out on the next example as well. Finally, we are going to plot and connect the points as a smooth curve, making sure there's no point at our vertex. So we've got 0, 8, 1, 5, 2, 4. Now remember, 2, 4 was our vertex, so now that's our turning point. So our parabola should start to go back up after our vertex. 3, 5, and 4, 8. So I'm going to make one smooth curve. I'm coming down to meet the vertex and then turning to go back up. Again, make sure you've got a nice curve there at the vertex, not a point. Let's take a look at one more, and then we'll move on to some that are a little bit more challenging mathematically, but it's the same process. All right, figure out what your vertex is. Coming out of the asylum is a -1. The 3 is already outside the asylum, so that stays positive. Set up your t-table. Put that vertex right in the middle and choose 2 points on either side. So -2, -3, 0, 1. Substitute those x-coordinates into your function to solve for your y value. Substituting -3 in for x. -3 plus 1 is -2. -2 squared is 4, but then we've got this negative that was on the outside of the parentheses. So it makes our answer -4 plus 3, which is -1. Substituting -2 in. -2 plus 1 squared is 1. But again, we've got that negative that makes it a -1, plus 3 is 2. Substituting 0 in. 1 squared is 1, but that negative on the outside makes it a -1, plus 3 is 2. And finally, substituting in 1. 1 plus 1 squared is 2. Sorry, 1 plus 1 is 2. Squared is 4, but we've got that negative on the outside again. And -4 plus 3 is -1. So as long as the points that you choose are the same distance from the vertex, this pattern, -1, 2, 3, 2, -1, will continue for all of your parabolas. So it actually cuts down the work, or it gives you a check to make sure that your t-table is correct. If your t-table doesn't have this symmetry, and you chose points that are in order under your x, then you have to go back and find your mistake. So now we're going to plot our points and make our nice smooth parabola. So we've got -3, -1, -2, 2, -1, 3, which was our vertex. So we're going to change direction, 0, 2, and 1, negative 1. So when you're plotting your points, think about it. As you plot that vertex, you should be changing direction after the vertex. In this case, our parabola opens down instead of up. So when we graph this, we're coming up to our vertex and then curving back down.